Hi, in this video we're going to learn how to calculate equilibrium with weak acids. So let's quickly review how to calculate equilibrium for strong acids. And let's say we want to calculate equilibrium for every single species when 0.10 molar of HCl. Now HCl we learned is a strong acid. So when you do HCl plus H2O single arrow makes H3O plus Cl minus. Now since 100% of the HCl will dissociate in water, because that's what happens to strong acids, this is going to be 0.1 m, this is going to be 0.1 m, change is going to be 0.1 m, remaining resulting in 0 remaining. ClO will have 0, and so the Cl will have 0, and then since all of this 0.1 will be used up, will form plus 0.1 molar of this and plus 0.1 molar of this, which gives us 0.1 m and 0.1 m. Now what is the pH for this? Well, pH is equal to negative log concentration of H3O plus, and pH will equal to the negative log of 0.10 molar, which will equal to 0.1, which will equal to 1.00 pH. Now pH significant figures is only you only count the significant digits after the decimal point. So this will be 1.00 will actually be two significant figures. Now strong bases works just like strong acids. So if I have 0.10 molar of BaOH2, right, because Ba is 2 plus, then over here it's going to be BaOH2 will form you Ba2 plus and 2OH minus. And acids ionize in water while bases dissociate. So this will be 0.1, 0.1 as well. And over here, since there's 2OH, we're going to have to do plus 2 over 1 times 0.1, which will give us 0.2. Now basically the key point here is when you're dealing with a strong acid or base that contains 2 of the H or acid and you have 2 of the H or OH, then you're gonna have to remember to use to use 2 over 1. And the same goes here. This will be concentration of OH minus, which will be 0.2. Since the concentration of OH minus over here, and if you plug that in, you're gonna get POH. You get a POH of 0.7, and pH will be 14 minus 0.7, which is 13.30. Alright, now that's for strong acids and strong bases. Now weak acids only partially ionize in water. And nitrous acid is a weak acid, for example. Nitrous acid, HNO2, aqueous plus H2O liquid. And we're gonna show when you're dealing with weak acids, we're gonna show the equilibrium expression with a double arrow, H3O, because it's not gonna completely ionize in water, plus NO2 minus. Now this is an example of a weak acid reaction. And now let's learn about the new equilibrium constant. The equilibrium constant for acid ionization is called the acid ionization constant, Ka. Now it tells us how likely an acid is to ionize, and the greater the Ka, the stronger the acid. And Ka is determined like any other equilibrium constant. It's going to be the concentration of products to the most power divided by the concentration of reactants to the most power. And since we're dealing with acids, it's going to be aqueous. Okay, now let's do an example over here. So we need to calculate the pH of a 0.5 molar HNO2 solution. First, we need to make a rice chart. So HNO2 aqueous plus H2O liquid will form equilibrium H3O plus NO2 minus. And H2O plus will be aqueous, NO minus will also be aqueous. Another way to tell if an acid is strong or weak is by looking for the double arrow. Double arrow means it's weak acid, and another way you can tell is that HNO2 is not one of the strong acids we learned, and anything that's not one of the 6 strong acids we learned will be a weak acid. Now initial we are given with 0.5 molar, and what are we're looking for the pH. So this will be minus x, this will be 0.50 minus x, this will be 0, x plus x, x, 0 plus x, x. Now how do we solve for the pH? Well, to solve pH, we're going to use Ka. Now if you look here, this is a list of Ka values that is given. You're not required to memorize these all the Ka, and they will be given. So let's see what we're looking for. We're looking for HNO2 is 4.0 times 10 to the negative 4. 4.0 times 10 to the negative 4. So Ka is equal to 4.0 times 10 to the negative 4. And this will equal to concentration of products, which is X and X squared over reactants. Water we don't count. It's going to be 0.50 minus X. Now we can simply plug this into the calculator. We can move this to the left side. We can move this to the right side and use a y equal expression. So x squared divided by 0.5 minus x minus 4.0 e to the negative fourth. Give us x value equals 0.01394. And now what is the pH? Well, pH is equal to the negative log concentration of H3O plus. So what is the concentration of H3O plus at equilibrium? X. What is X? We just found that out. So pH will be equal to negative log of 0.01394. And then if we do that, negative log of 0.01394 will give us 1.87. In the next example, we're given the pH. It says the pH of a monoprotic acid is 5.15 and the molarity is 0.10 molar. Now what does monoprotic mean? Now monoprotic acid means an acid that can only donate one proton, and if you only have one H, you can only donate one proton. So since we're not given the acid, let's just use A as a placeholder. Now our question is, what is Ka and what is the percent ionization? So let's use HA plus H2O forms equilibrium with H3O plus A minus. Now we're given with 0.1 molar, so minus X is 0.1 M minus X. This is 0, 0 plus X. This will be X. Okay, now we're here, we can find pH is equal to negative log of H3O plus and we can find H2O plus by using the reverse formula, which is 10 to the negative pH's power. pH we're given with 5.15. So what is our concentration of H2O plus? 10 to the negative 5.15 is equal to 0.79 times 10 to the negative 6. And this is the concentration of H3O plus at equilibrium, which is X. So concentration of H3O plus equals the concentration of A minus at equilibrium equals 7.1 times 10 to the negative 6. How about HA? HA is 0.1 minus the previous number we just found, which will give you 0.0999, which is we can round it to 0.1. Now what is the Ka value? So Ka, we're looking for Ka. Ka is equal to X squared divided by 0.1 minus X. X squared is equal to 7.0794 times 10 to the negative 6 power, and 0.1 minus X. As we here, 0.1 minus X we found is equal to 0.1 because of how small X is. And now what that tells us, there's a new rule that I'm gonna show you here, and that is if the Ka value is less than 1.0 times 10 to the negative 4, then you can ignore the K when you are subtracting it in the denominator. So this is just going to be 0.1. And we just showed you y over here. After you subtract the x, it's basically the same thing. So now if we know the formula for K, we can simply plug it to the calculator. 7.0794 gives us Ka equals 5.01, which is 5.0 times 10 to the negative 10th power. Now that is K. What is percent ionization? Percent ionization is equal to the concentration of A minus over HA. Both at equilibrium. So what is the concentration of A minus, which is X, which is 7.1 times 10 to the negative 6, over our original, 0.1 molar, 0.1, which will equal to 7.1 e to the negative 6, divided by 0.1 will give you 7.1 times 10 to the negative 5th. But that is not a percentage, so we're going to have to multiply by 100 times 100, which would give us 0.0071%, or 7.1 times 10 to the negative 3rd percent.